Hi, my name is Matt Adams. I'd like to talk to you today about a new product for the MAP 200, the MTFX C1 multi-port tunable filter. It's a next generation tunable filter for test and manufacturing applications. It's a new fundamental technology that enables signal management at a wavelength level. As far as the device is concerned, single input allows you to generate up to 80 virtual tunable filters. Each tunable filter can be individually managed. The filter is managed by changing its bandwidth, center wavelength, and can be set anywhere in the C-band. It comes with a very intuitive, simple to use touchscreen. The interface to control the filter is very simple. A filter is created by selecting out of the channel list, can be edited. Each virtual filter has basically 4 properties: a center wavelength, a bandwidth, an attenuation, and what output port you want the signal to be expressed on. To edit, you simply come into the GUI, select which frequency you want the channel to show up on. So in this case, I'll change it from 192 terahertz, and I'll express it out to 194.5. Simply enter in the wavelength and accept the parameter. Okay. At the moment, I have up to 6 filters. I can have up to 80 individual filters, which allows you to manage multiple signals simultaneously. Okay? If I want to change the physical output port, again, I would select from the list, come into my main interface, and simply change what channel I want the device to be, what physical output channel I want to be expressed to. So today what I'm doing is I'm evaluating this filter using our swept wavelength system. What I'm doing is I'm sweeping a tunable laser through the input common, and that allows me to measure and verify the channels that I've created through the filter interface. So on the screen I'm showing the result of the filters that I've programmed. Each one of these peaks represents an individual filter that I've created through the device. So each one of these filters could represent a test channel that I'm looking at. Right? So if I zoom in on one of the channels, and we look in real close, you can see 5 dB insertion loss, less than 5 dB insertion loss, very flat across the wavelength band. To give you a sense of the granularity that I have, I'll go in and I'll select this filter for editing, and I'll show you sort of the degree to which I can manage and control it. So to do that, this is the filter at 192.5. I come to my channel list, highlight it, go into the edit mode. If I change the bandwidth from 200 gigahertz down to 100 gigahertz, and I'm going to change it from being a square top device to being a Gaussian device, a Gaussian channel profile. Accept the parameters. Okay. And now I see I've managed and changed the property of the filter in 3 or 4 easy steps. So in this case, I have a Gaussian profile rather than a square top profile. The Gaussian profile is particularly valuable in test applications because it gives you an unambiguous signal or an unambiguous ability to understand whether your channel is aligned to your carrier. So if you imagine having a carrier somewhere aligned in this channel, by having a Gaussian shape, I have a really easy method of understanding that my channel and my carrier are well aligned. If I don't want the Gaussian profile, again, it's a relatively easy toggle. So again, I would select my filter at 192.5 out of my channel list and change it to a square top, accept the parameters. As the screen refreshes, you'll see that I'm going to change from the Gaussian profile back to my square top profile. So thanks for watching the video. A couple of key features to remember. A very powerful wavelength management solution, 5 dB insertion loss, up to 80 virtual tunable filters with a simple, intuitive graphical interface. Thanks for watching. If you need more information on the device, look at us on the web at VIAVIsolutions.com.